Morning students. Today we are going to discuss about the special type of integral problem based on the properties of integral. Okay. So first the problem is integral 0 to pi by 2 log of sin x dx. Okay. Or integral 0 to pi by 2 log of cos x dx. The problem with log of sin x dx for the limit 0 to pi by 2 and log of cos x dx for the limit 0 to pi by 2 have same answer. Okay? Listen. So first, the solution of the problem, let us consider the integral I is equal to 0 to pi by 2 log of sin x dx as equation number 1. Take this as equation number 1. Now we are going to apply the property. Okay, that is by property integral 0 to a f of x dx is equal to 0 to a f of a minus x dx. By applying this property, now x is changed into pi by 2 minus x. So this x is changed into pi by 2 minus x. So the sine of pi by 2 minus x becomes cos x. So this integral I is equal to integral 0 to pi by 2 log of sine of pi by 2 minus x into dx. We know that sine of pi by 2 minus x can be written as integral 0 to pi by 2 log of cos x dx. Take this as equation number 2. Now add 1 and 2. Now 1 plus 2 implies 2y is equal to integral 0 to pi by 2 log of sin x dx plus 0 to pi by 2 log of cos x dx. Now here we are going to apply the formula log m plus log n is equal to log mn. So this is log m and this is log n. Now apply these. Log m plus log n is equal to log mn. We get 2y is equal to integral 0 to pi by 2 log of sin x cos x dx. Now again we are going to apply here sin x into cos x is equal to sin 2x by 2. Now apply this formula, that is sin x into cos x is equal to sin 2x by 2. So now this integral is converted into 2y is equal to integral 0 to pi by 2 log of sin 2x by 2 into dx. Again, here we are going to apply log m by n is equal to log m minus log n. So now this integral 2y can be written as integral 0 to pi by 2 log of sin 2x dx minus integral 0 to pi by 2 log 2 into dx. This is log m minus log n. Okay. Now here we are going to substitute the value 2x as t. So now put t equal to 2x. So dt equal to 2 times of dx. dt by 2 is equal to dx. So whenever the variable changes, the limit also changes. So the limit, that is for x, the limit is 0 to pi by 2. For t, that is 2x. Okay, that is 2 times of 0, 2 times of pi by 2. So this is 0 to pi. So now the same integral 2y is equal to integral 0 to pi log of sin t into dt by 2. Okay. Now here This log 2 is constant. This is constant. So take this log 2, we get this times of dx. Integral 0 to pi by 2 times of dx. Here, again we are going to apply the property. By property, integral 0 to 2a f of x dx is equal to 2 times of integral 0 to a f of x dx if f of 2a minus x is equal to f of x. That is sine of pi minus t is equal to sine t. Sine of pi minus t is equal to again sine t. That is f of 2a minus x is equal to f of x. So this can be written as 2 times of here pi by 2. 2 times of pi by 2. So we get 2y is equal to 2 times of, here 1 by 2 already is there. So 1 by 2 times of 2 times of 0 to pi by 2 log of sine t into dt. So 2 cancel. Here log 2, this is integral of dx is equal to x, limit 0 to pi by 2. Now this is nothing but I, because integral 0 to pi by 2 log of sin x dx is I. So integral 0 to pi by 2 log of sin t dt is also I, because this x and t are considered as dummy variable. Whatever the variable may be, the limits are changed and the integrand are same, so it takes same value. So this is 2y is equal to I minus log 2 times of pi by 2 minus 0. Now 2y minus I is equal to minus pi by 2 log 2 is the answer. Okay, clear? For integral 0 to pi by 2 log of cos x dx. Okay, first you apply the property, you get sin x. Again you add cos and sin, again you get the same result. Proceed as it is, you get the same answer. Okay, for the problem integral 0 to pi by 2 log of sin x dx or integral 0 to pi by 2 log of cos x dx, the answer is minus pi by 2 log 2. Okay, this is very important problem. Okay, thank you students.